Electrically powered devices are essential elements of many lab work areas and can pose a significant hazard to workers, especially when they are mishandled or maintained poorly. Potentially hazardous equipment include hot plates, vacuum pumps, electrophoresis equipment, lasers, ultrasonicators, and power supplies. Many electrical devices have high voltage or high power requirements, carrying even more risk. Some devices even contain large capacitors and are capable of storing lethal amounts of electrical energy. These pose a serious danger even if the power source has been disconnected. One major hazard associated with electrical equipment is electrical shock, which happens when the body becomes part of an electric circuit. This can occur either by contacting two separate parts of a circuit, or by contacting one part of the circuit and the ground, or a metallic part that has become energized by contact with an electrical conductor, resulting in static shock. The severity and effects of an electrical shock depend on a number of factors. The first factor is the amount of current. Even an intermediate voltage can be deadly if the conditions for high current flow are right. In that same vein, we have the second factor, skin condition, or whether the skin is wet or dry. Water is a great conductor of electricity, allowing current to flow more easily in wet conditions and through wet skin. Next is the duration of the exposure. And finally, the pathway that the current takes through the victim's body. We can start to look at the physiological effects on the body by considering the most readily available conduit for electrical current in the body, the nervous system. The nervous system is made up of special cells called neurons, which conduct electrical signals and tell the muscles what to do. If too large a current is passed through the nervous system, these signals are overridden, interrupting communication between the muscles and the brain. In fact, the muscle response to a large external current is to contract, and in many cases there's nothing the victim can do about it. This contraction is especially dangerous if the victim contacts an energized circuit with his or her hands. The forearm muscles responsible for bending the fingers tend to be better developed than those muscles responsible for extending the fingers. And so if both sets of muscles try to contract at the same time because of an electrical current, the bending muscles will win, clenching the fingers into a fist. This involuntary clenching makes the situation even worse. Felipe now has excellent contact with the wire, and there's very little likelihood he'll let go. Another danger is when both hands contact the equipment in such a way that the current passes from one hand to the other through the chest cavity. A strong enough current taking this path can cause asphyxiation or even heart failure. For this reason, it's sometimes best to keep one hand in your pocket when working with electronics. Assuming the conditions for electrical conduction are ideal, that is, lots of skin moisture, sustained contact, and a clear path throughout the nervous system, expect the following effects for different voltages. You'll experience a tingling sensation at 1 volt, a slight shock at 5 volts, a somewhat painful shock at 6 volts, sustained muscular contraction at 10 to 20 volts. This is the can't let go range. There will be extreme pain and respiratory arrest at 50 to 150 volts. Ventricular fibrillation at 300 volts. At this level, shock can be fatal if it's continued. The victim will exhibit respiratory paralysis and possibly burns at 6,000 volts. And finally, at 10,000 volts, you can expect cardiac arrest and severe burns. Electrical shocks above this level are highly lethal. Fire is another major hazard associated with electrical equipment. Electrical equipment and wires present more fire hazards than you might expect. Heat from energized equipment or overloaded cords, and sparks from short circuits, faulty connections, or frayed cords can act as an ignition source. These ignition sources could combine with even small amounts of flammable vapor to start a fire that may even flash back to the vapor source. Please observe the following safety precautions to keep you safe and maintain a safe working area. Always consult your supervisor if you're not sure of something. Regularly inspect the equipment wiring. Do not use equipment if the wiring is obviously frayed or damaged. Notify your TA or supervisor immediately. Learn the location of shutoff switches and circuit breaker panels in the lab. Use these to cut power to the equipment if there's a fire, a spill, or an electrocution. Limit extension cords and only use them for temporary operations. If necessary, a TA can request installation of a new electrical outlet. Reduce working on electronics near sources of water. If there's a spill near a piece of electronic equipment and you can safely access the cord without contacting the liquid, unplug it. Avoid contact with an open electronics box if possible. Otherwise, keep one hand in your pocket. Disconnect electronics before troubleshooting. Make sure your hands are dry while working with electronics. If there is a short in the circuit or a current overload in your electronics, you may see a spark or smoking equipment. In this case, unplug it if you can safely reach the cord. To help someone escape electrocution, make sure you are not wet or standing on a wet surface. Unplug the power source. Use non-conductive materials to pull the victim from the electrical source. Do not touch the victim.